So today we're going to talk about DNA translation. So here I have a DNA strand, and in my previous video on what is DNA, and I have in the link in the description below, I said about how DNA is the code for proteins and amino acids. But have you ever wondered how we can uncode the proteins coded in the DNA strands? Well, to do this, we do a process called DNA translation. So here we have our DNA strand. And it's gonna be located in the cell nucleus. And since you could think of the cell nucleus like a safe, and somebody has to go get the information out of the safe and give it to the builders who are located outside the cell nucleus. To do that, we have the mRNA, the messenger RNA. The messenger RNA is going to do a process called DNA transcription and code the DNA's information on it. So to do this, first we're going to unwind our DNA. And we're going to find the letter code on the DNA strand. And this is a random code I made up. And so here, as you can see, this is a letter code, so T. And so we have A. A stands for adenine. And I made my What is DNA video. I talked more in detail about this. But let me just give you a review. So A stands for adenine. C stands for cytosine. G stands for guanine, and T stands for thymine. So these are the four letters of DNA code: adenine, cytosine, guanine, and thymine. And so adenosine always bonds with thymine, cytosine always bonds with guanine. So T, A, C, T, T, C, A, G, T, and so forth. Now we're going to find the matching mRNA sequence. So this matching mRNA sequence matches. And the only difference we're going to have here is that instead adenine is going to bond with uracil or U. So TA, AU, CG, TA. So thymine bonds with adenine, CG, AU, GC, and we'll have more and more. So keep on going so forth. So TA, AU, TA. And so this is now the matching mRNA sequence, since it has the same information, since it matches the DNA sequence. So it has the same information. So now we can transport this mRNA outside the cell nucleus to the builders or the ribosomes. So the ribosomes are not going to be able to read the sequence. What they're going to do is they're going to build the amino acids matching it. To read it, we need something we call the TRNA. The TRNA are just like RNA, and they're going to be able to bond to the RNA. And just like if you have a lot of magnets, and you want to figure, you're closing your eyes, and you want to figure out what pole is facing you, the easiest way to do that is to figure out if the south pole or the north pole, if it attracts or repels, right? So the same thing. If it bonds, then we know what codon is there. And I'll explain what a codon is in a minute. So here I have the letter code. And so codons are pairs of 3 letters. AUG is one codon, AAG will be a codon. And so the tRNA are going to bond to these codons. And so if a tRNA bonds to a codon, then we know what the codon is. So now for the first codon it's gonna match is AUG. And so AUG this tRNA is not gonna take any protein. Instead, it's just gonna start the process. The next codon is TTC. Next tRNA has TTC and it's AAG. And so the TTC tRNA is gonna bring with it an amino acid. And the ribosome is going to take this amino acid and put it into a bond. So let's first see what this amino acid is. So here I have a chart of the amino acids with the codes they will match to. So it's AAG. So we're going to take AAG. That is lysine. So the amino acid is lysine. Now the ribosome is going to bond this with the next amino acid. So it's TTC. They're going to bond it with UCA. So AGT, UCA. So let's check what UCA is. UCA, that's serine. So the ribosome is going to bond serine to lysine. And now let's check the next codon, UAU. It's going to bond with ATA, and ATA tRNA is going to bring with it an amino acid, UAU, so tyrosine. Now the ribosome is going to take that tyrosine and bond it to the existing chain. And we're going to keep doing this. GCG, take the matching tRNA. That's going to bring our matching amino acids. Check GCG, GCG, it'll be alanine. And next, we have AGA. So let's check that. UCU, UCU. And so that would be UCU, it would be serine again. So UCA and UCU are the same thing. So then the ribosome is going to again put that into the chain. And then we have UAG. And UAG, if you check, UAG is the stop signal. Well, basically, it's going to stop the process. So now our peptide, our chain is lysine bonded with serine bonded with tyrosine bonded with alanine bonded with serine. And since this is only 5 amino acids bonded together, we'll call this a peptide chain, not a protein, because proteins are complex peptide chains, and peptide chains are just small bonds of amino acids. So this will be a peptide chain. And so now this peptide chain is going to do functions in the cell. Thank you for watching. I hope you enjoyed this video. As always, watch my video on bacteria over here and my video on what is DNA over here. Subscribe to Kids Teach Kids and stay tuned. Bye!